Good afternoon, ladies and gentlemen. Welcome to my presentation. So I'm going to talk about the power electronics for renewable energy. But I was thinking that why power electronics for renewable energies? Why power electronics not only for renewable energy? This is important. So I'm going to talk about why do we need power electronics in our society? So imagine a world without electricity. No lights, no smartphone, no internet, no electric vehicles. Seems that our life is highly rely on reliable energy sources. So electricity brings lots of benefit for us, and also if we compare, we can see that now we have a high level quality of life by use of electricity in our society. But there is a big challenge. We generate electricity from fossil fuel-based energy sources, which they are highly probably provide lots of emission for our society, and they are not good for our environment. So this is why we should think about the other part. So just get back to this two graph. The left side shows the temperature of the Earth from the time that Thomas Edison and Nikola Tesla developed the DC and AC generators in 1880. And it seems that from that time, up to today, the temperature of Earth increased 1.47 degrees Celsius. So it's very bad news for us. And if we compare with the right side, and we see that, this is the CO2 emission from 1960. And if we compare two graphs, we see that in 1960, we had also a little bit of not very different, but they have almost similar ramp. It's a very sharp. So it seems that they are highly tied, and they are because of this power plant that provide the electricity for the different sectors like industrial and commercial, transportation, and also residential buildings. So for this case, lots of countries think about the providing the electricity from non-renewable energy sources. So if we just example, we see the electricity production in USA in year 2022. We see that we have different types of the energy sources based on renewable and non-renewable energy sources. And but the emission is coming from the non-renewable energy sources, and we don't have any emission from renewable energy sources except this nuclear, which is not renewable energy, but it's free of emissions. So it provides some nuclear waste. So for this case, European also was too active to provide the electricity from renewable energy sources. And if we see the average level of the electricity we have in 2023 in European Union is 24.5% in comparison with year 2010, which was 12.5%. We have almost 2 times more, but this is not what we are looking for our society. So it's not enough. But some countries like Sweden, they had actually a leading position. They provide 66.4% electricity from renewable energy sources. And also good news is that Finland has the second place by providing electricity from renewable energy sources 50.8%. But the data is from 2023, and we had also some target in Finland, and I'm pretty sure that now is much more than 50% that we had 2023. But European Union has ambition target to reach 42.5% electricity from renewable energies by 2030, and with ambition target of 45%. So for this case, Finland, as a leading country in carbon neutrality target, toward the carbon neutrality targets, they provide some energy transition targets. We are going to reach to carbon neutrality in Finland by 2035. We are going to provide all electricity from renewable energy sources before 2050. And we are going to also adapt 700,000 electric vehicles in Finnish routes by 2030. We are going to phasing out coal-fired power plants by 2029, and we are going to invest huge amount of money in this direction continuously. So they are not the only targets. So for example, Finland has the potential from the wind perspective. So we are going to use this potential to provide the 10% of green hydrogen by 2030 and take the leading position for this technology. So we have plenty of targets in Finland, and the progress was really good. But transitioning from non-renewable energy to renewable energy is not that much easy. We said that we have this target and then we reach that one. So for example, we have wind, we have solar, they are renewable energy sources and they are everywhere, available everywhere. But the problem is that the wind speed is not constant, and you cannot say that, we have wind today or tomorrow, they are the same and we can provide that much power. And the radiation in solar is not also the constant. The morning is different from afternoon. During the night, we don't have. Today, we have very good, actually, sun. Tomorrow probably is a rainy day and we don't have it. So they are very variable. They are not actually constant power that we can say that they are reliable source of energy. So here is the place where power electronics come in. So just a simple example. Assuming that you have a power plant which provides the electricity from the wind. Wind speed is not constant, so it's variable. And what we provide is like this. And it's unregulated electricity which we cannot use or cannot connect our devices to that one. So what is happening, it damage and lead to malfunction of our appliance if we connect directly to this generation. So for this, we can use the power electronic devices. We call it rectifier. So rectifier is an interface between, actually, after power electronics, after generation with the other part. So we change the nature of the unregulated generated power from wind to a DC power. So this DC, after regulation, can be input as an input for another conversion system that we call it inverter. Inverter convert the DC power to the AC, and this is what we are looking for. So we had the input unregulated AC power, but the output is sinusoidal with the frequency and voltage level that we need. So if we are living in Finland, the frequency is 50, but for North America is 60. So this is why we use the power electronic to provide what we need in our society. And the role of the wind is highly important in any countries, especially Finland's, and they can be integrated with any level. So we need the power electronics between the wind turbine, generation, and the consumption. So we cannot definitely ignore the role of the power electronics in this case. Otherwise, we get in the problematic situation to use the power generated by green energy sources to load centers. So in my group, renewable energies for power system, we are developing advanced control technologies for control of the power electronics, for integration of renewable energy sources and energy storage devices to the power grid or load centers. So we are going to develop a conversion system to provide efficient, reliable, high-quality, resilience, and a stable energy for the load centers from unreliable and variable source of energy from renewable side. So just a simple example, assuming that you're going to provide electricity for a hospital. So we have operating room. In operating room, we have ventilators, we have monitoring systems that measure the oxygen, heart rate of the patients, and also we have lots of surgical equipments. We have lighting system, and just assuming that, just for 1 second, we lose the electricity. What is happening? So then it endangered the patient lives seriously. So now we get back that is really our power system 100% reliable or not? We said that in Finland we have a very strong grid, but we cannot say that it is 100% reliable. So even 99% is not reliable enough. Why? Because assuming that if it is 99% enough reliable, so each 100 patient, one of them will die because of the unreliability. So here is the power electronic can provide 100% reliable energy for such applications. So we can use the local power generation plus storage devices to provide the reliable electricity close to the load centers. And the next part is that for the some sensitive loads. So again, gets back to the same example. So we have these monitoring devices that measure the oxygen and also heart rating of the patient. So if we have unreliable or probably low quality power electricity, then these devices are highly sensitive, and the data will be wrong, and it also provides the damage to the life of the patient. So this is very important that we consider that power electronic can provide high quality with high reliability electricity for such applications that we need in our daily life. Also, one other important thing is that the consumption is different at 11 p.m. or 11 a.m. So in 11 p.m. people are not working, they are sleeping, and the consumption is very, very low. But during the 11 p.m., we have 11 a.m., everybody works, and also we have a high stress over the grid. So if we provide the electricity for ourselves by PV at our roof, so we can reduce the stress over the grid and increase the stability of the grid. And then we have also this possibility to, by use of the power electronic devices, we inject kinetic energy to the power grid to provide the strength of the grid and also regulate the voltage and frequency of the power grid. So it can support our network, and it is essential for our society. So we should consider also that we have different types of the energy sources, and wind is AC, solar is DC, fuel cell is DC. So we should be consider this, that power electronics is a main player to match the generation with the consumption. So now I get back again to the topic, power electronic, why not only for renewable energy? So we go to carbon neutrality, and renewable energy provide or power the future. But the power electronics make that future possible. From integrating renewable energy sources and also stabilizing our complex power grid and electrifying how we live, power electronic is not just a technical solution. It is societal enabler. This is why power electronic is not only for renewable energies. It is essential for our society. Thank you very much for your attention.